March 1941. The world was already at war, and in factories across the United States, men and women worked around the clock to produce the tools of victory. Among these factories, one stood out, the Ford plant in Willow Run, Michigan. This wasn't just any factory. It was a vast, humming monument to American ingenuity, tasked with building the new bomber that would soon dominate the skies, the consolidated B-24 Liberator. To most people, the B-24 was just another heavy bomber, 4 engines, a formidable payload, and an intimidating nose. But what few realized at the time was that a single, seemingly insignificant decision made on the factory floor would transform the B-24 into a bomber with a range that stunned both allies and enemies alike. The story begins with a rivet. Not a special rivet, not a high-tech component, but a simple, ordinary piece of hardware used to hold the metal skin of the aircraft together. Every B-24 flying off the Willow Run line was covered in thousands of these rivets, each hammered into place by hand by workers whose job was repetitive, exhausting, and precise. One misaligned rivet, one slight change in the spacing or pattern, could mean the difference between a plane that performed as expected and one that failed catastrophically in the air. Inside the factory, there were rumors, whispered in the clang of steel and the hiss of pneumatic drills, about stupid layouts, mistakes in the assembly lines that no engineer had intended. Some rivets, some panels, some seams workers had started to experiment subtly, not officially, not sanctioned, but through tiny adjustments, tiny improvisations born from boredom, fatigue, or simple curiosity. The metal skin of the B-24 began to take on patterns that weren't on the blueprints. And it was here, in the hum of a giant assembly line, that a single worker made a decision so small, so trivial, that no one could have predicted its consequences. This worker was not an engineer. He didn't hold a degree in aerodynamics. He was just another hand in the chain, assigned to place rivets along a particular wing panel. But he noticed something, a slight bulge, a minor drag in the airflow over the surface. In his mind, he thought, what if I space these a little differently? It wasn't a theory. It wasn't a calculation. It was instinct. He adjusted the rivets ever so slightly. A subtle change. A tiny difference that, on paper, seemed irrelevant. Almost laughable. When the B-24 with this stupid rivet layout took to the skies, no one expected much. The engineers had already done the math. They had projected maximum ranges, fuel consumption, payloads, and top speeds. Every B-24 was supposed to fly a certain distance under a certain load. But as the test flights began, something extraordinary happened. The planes didn't just meet expectations, they exceeded them. Mile after mile, the bombers seemed to stretch further, glide smoother, and sip fuel more efficiently than any calculations had predicted. Word began to spread quietly through the factory and the engineering teams. These planes were flying farther, and soon the reports came in from the front lines. Bomber groups flying missions over Europe and the Pacific found that their B-24 could reach targets that had been considered impossible for heavy bombers. Missions that had been designed as two-stage flights now became direct strikes. Entire planning strategies changed because these planes had range that no one had imagined. Historians would later debate exactly why the change in rivet layout made such a difference. Some argued it reduced drag, creating a more aerodynamic surface. Others pointed to the way the slight bulges influenced airflow over the wings and fuselage, subtly stabilizing the aircraft in flight. But whatever the exact mechanism, the result was undeniable. These B-24 could carry more fuel, fly further, and arrive at their targets with more reserves than any of the engineers had anticipated. And yet, amidst this technological marvel, the man responsible remained anonymous for years. He returned to his station each day, placing rivets, following instructions, unaware that his instinctive adjustment had rewritten the capabilities of one of the most important bombers of the Second World War. To the outside world, he was just another factory worker. But in the skies over Europe, the B-24 he had helped assemble were performing miracles. By 1943, the B-24 was everywhere. In the European theater, crews relied on its extended range to reach strategic targets deep inside Nazi-held territory. In the Pacific, Island-hopping campaigns depended on its ability to fly long distances over water, where the slightest miscalculation could mean life or death. And while the pilots, navigators, and gunners received medals and accolades, the story of the stupid rivet layout remained hidden, whispered only among a few engineers and the curious historians who pieced together factory records decades later. The B-24's fame was immense, but it was never just about the engineer's blueprints or the factory's production line. It was about human instinct, small choices, and the hidden ingenuity of ordinary people doing extraordinary work under extraordinary pressure. It was about the quiet, unnoticed heroism of someone who trusted their gut over a drawing board. And it all started with a rivet. As the war raged on, more and more B-24's rolled off the line at Willow Run. Each one carried the legacy of that tiny, stupid adjustment, a secret ingredient that no enemy, no strategist, no engineer could have fully predicted. The story of the B-24's extended range isn't just a story of design or engineering, it's a story of intuition, human error that became brilliance, and the hidden threads that make history unpredictable. It's easy to imagine a bomber winged across the Atlantic, engines roaring, bombs loaded, flak bursting around it, and crews counting on every mile of range to bring them home. But behind that immense power, behind that roaring metal bird, was a quiet, overlooked moment in a factory somewhere in Michigan. One worker, one rivet, one instinctive choice, altering the course of missions, saving lives, and changing the strategic calculations of a global war. In the end, the B-24 was more than just a bomber. It became a symbol of American industrial might, ingenuity, and the hidden genius in ordinary work. And that genius, that spark of intuition, came from a place no one expected, a rivet, a small adjustment, and a worker who trusted his instincts in a world governed by rules, blueprints, and calculations. The next part of this story goes deeper into the missions, the pilots, and the remarkable feats that resulted from that tiny adjustment. It's a story of courage, of audacity, and of a bomber that could fly farther than anyone dared to imagine, all because of one seemingly insignificant choice in the heart of a factory. As the B-24's with the stupid rivet layout began reaching air bases across the country, crews quickly noticed something remarkable. Training missions that were supposed to push the aircraft to its limits revealed a surprising truth. These bombers could fly farther, carry more, and perform more reliably than the manuals suggested. Pilots whispered about it in hushed tones, how a fully loaded B-24, heavy with bombs and fuel, would seem to glide effortlessly across the sky, its engines humming in perfect balance, while others had struggled to reach similar distances. In Europe, the effect became undeniable. Early 1943 saw the B-24's being deployed on missions that would have been considered impossible just a year before. The famous Schweinfurt raids, notorious for their danger and distance, suddenly became feasible with these extended-range Liberators. Bombers could leave from bases in England and strike deep into the heart of Germany, hitting industrial targets thought out of reach for any heavy bomber. Crews who had once calculated the risks down to the last gallon of fuel suddenly found themselves with a few extra miles in reserve, a buffer that meant life or death in the unforgiving sky. And it wasn't just the range. The slightly altered rivet pattern seemed to improve handling as well. Some pilots noted that turbulence, which could throw off formation flying or make bombing runs more hazardous, was less severe on these planes. The aircraft felt smoother, almost as if it were slicing through the air rather than fighting against it. For bomber crews facing anti-aircraft fire and enemy fighters, every small advantage mattered. And here it was, delivered by a factory worker who had no idea of the strategic consequences of his action. Fuel efficiency became the subject of fascination among the engineers who were now puzzling over these anomalies. Flight logs showed that B-24's with this subtle rivet pattern consumed significantly less fuel per mile than expected. Analysts initially dismissed it as a fluke, a variation in pilot technique or weight distribution. But as reports accumulated, the pattern became clear. Something about the airflow over the fuselage and wings, disrupted ever so slightly by the altered rivet layout, reduced drag and optimized lift. What had seemed like a careless tweak, a stupid layout was, in fact, an aerodynamic marvel born entirely by accident. The strategic impact was immediate. Commanders began planning longer-range missions, striking industrial centers, supply depots, and airfields that had previously been safe from Allied bombers. The German Luftwaffe, already stretched thin, struggled to respond. Anti-aircraft batteries that had been positioned to defend closer targets were no longer sufficient. The B-24 crews could come in from unexpected directions, attack vital targets, and return home without the need for refueling stops or intermediate bases. Every successful mission chipped away at the enemy's war machine, and all the while, the secret behind this extraordinary range remained unknown outside the factories of Willow Run. Meanwhile, back in the Pacific, the B-24's were proving equally invaluable. Island-hopping campaigns demanded aircraft that could fly long distances over open ocean. The Liberator's newfound range allowed for strikes against remote Japanese-held islands, supplying reconnaissance teams and even rescuing downed airmen far from base. Pilots would often recount gripping tales of returning to their carriers or airstrips with barely a drop of fuel left, but they always made it thanks in large part to the subtle improvements hidden in their aircraft's construction. Crewmen started to develop superstitions around these planes, joking that certain B-24's were blessed or lucky because they seemed to outperform others. Little did they know, the source of that luck was mechanical but human, a rivet pattern no engineer had intended. Mechanics, oblivious at first, began to notice the difference during inspections, noting that these planes required less adjustment, less shimming, less tweaking overall. They were sturdier, smoother, and far more predictable in flight than their predecessors. As missions increased, so did the pressure. Pilots flew deeper into hostile territory, encountering flak, fighter attacks, and the constant threat of mechanical failure. Yet time and again, the B-24's delivered, their extended range allowing them to evade traps, reroute around unexpected defenses, and complete objectives that would have been impossible for other bombers. Stories emerged of crews flying for 12, 14, even 16 hours straight, reaching targets that had once been theoretical. Survivors spoke of the sensation of climbing above storm clouds, engines thrumming steadily, feeling as though the aircraft itself carried them with ease. The engineers, now aware of the anomaly, conducted wind tunnel tests, pored over flight logs, and attempted to replicate the effect intentionally. And while they could eventually recreate the benefits, they never quite captured the serendipity of that original factory tweak. What had been accidental was now legendary, a reminder that sometimes innovation doesn't come from design tables or calculations, but from intuition, human curiosity, and yes, even mistakes. Reports from bomber groups often mentioned the extra miles they seemed to gain. Crews would write letters home, describing flights that exceeded all expectations, marveling at how far they could go with full payloads. They had more fuel reserves, could carry heavier loads, and fly longer without rest. And in a war defined by attrition and logistics, every additional mile counted. Every extra pound of fuel saved meant one more mission completed, one more crew member returned home. In quiet moments, pilots and gunners began to speculate. Was it luck? Was it engineering genius? No one could explain it at first. And the factory workers, those who had spent hours hammering rivets in lines that seemed endless, didn't understand the full implications of their work. They were making aircraft, yes, but the subtle decisions made on the floor, spacing, alignment, minor adjustments, had changed the calculus of war. One stupid choice in a rivet layout had rippled across oceans and continents, influencing battles in ways no general could have planned. The B-24's performance began to overshadow expectations in other ways, too. Mission planning changed, strategies evolved, and commanders realized that the Liberator's new capabilities opened possibilities they had never imagined. Fleets could be deployed from unexpected bases, routes that were once impossible became standard, and Allied forces gained a tactical advantage that shifted the momentum in certain theaters of war. The quiet ingenuity of a factory floor worker had given the Allies a tool far more powerful than anyone had anticipated. Yet, amid all the accolades, medals, and headlines praising bomber crews, the worker responsible remained in the background. His contribution went unnoticed, overshadowed by the dramatic heroism of the men flying into flak-filled skies. And that anonymity only added to the legend of the B-24, an aircraft whose incredible range was both a secret weapon and a testament to the hidden brilliance found in the most ordinary corners of wartime industry. As we move into the final part of this story, we'll follow these bombers into their most daring missions, see the critical moments when that extra range made the difference between survival and disaster, and reveal how a single, accidental decision ultimately shaped history. The B-24, with its stupid rivet layout, wasn't just a machine of war, it was a story of human intuition, risk, and unexpected genius at the heart of one of the deadliest conflicts the world has ever known. By 1944, the B-24 with the stupid rivet layout were proving their worth in the most harrowing, high-stakes missions of the war. Over Europe, the skies were a gauntlet of anti-aircraft fire, enemy fighters, and unpredictable weather. Bomber groups often flew in tight formations, relying on each other for protection, knowing that a single mistake could mean the loss of an entire crew. But the extended range of the B-24 changed the game entirely. Routes that once required careful planning around enemy defenses were now direct, precise, and far more survivable. The extra miles of fuel meant pilots could climb above flak, avoid intercepting fighters, and still make it home without emergency stops. One mission, etched into the diaries of bomber crews, highlighted this advantage with devastating clarity. A formation of B-24's, loaded with incendiary bombs, took off from a base in southern England, headed for a target deep within the Ruhr Valley. Normally, such a raid would push the aircraft to the very limits of their range, forcing crews to calculate every ounce of fuel. But these B-24's had a margin the pilots didn't fully understand. As they approached the target, heavy clouds and unexpected flak forced the group to take a longer route, dodging anti-aircraft concentrations. With other bombers running low on fuel, some had to abort or turn back. But the B-24's with the subtle rivet layout pressed on, engines humming, wings slicing effortlessly through the turbulent air. They hit the target, delivered their payload, and returned safely. While planes built to the same specifications, but without the adjustment, were already struggling to make it back. Stories like this were repeated across theaters. Crews began to refer to these planes almost reverently, calling them miracle birds in quiet conversations. Navigators marveled at how much farther they could push, how much more accurately they could time their runs. Pilots discovered that the B-24's stability had improved in ways they couldn't explain. The aircraft, which had once been criticized for its tricky handling at low speeds, now responded with precision, almost as if the air itself welcomed it. In the Pacific, the Liberators were even more critical. Island-hopping campaigns demanded extreme endurance, flights over hundreds of miles of open ocean, often with no chance of rescue if anything went wrong. In one particularly daring raid, a squadron of B-24's took off from a base in Australia to strike Japanese airfields hundreds of miles away on New Guinea. Midway, bad weather forced a course deviation. Crews braced for disaster, calculating that their fuel reserves would not last. But the B-24's pressed on, reaching the target, delivering their bombs, and returning with fuel to spare a feat that other bombers simply could not manage. The difference? That subtle adjustment in the rivet layout, invisible to everyone, providing extra efficiency and stability that no one on the mission fully understood. Historians would later call this the Willow Run miracle, a reminder that war is often shaped by small, human choices as much as by strategy or machinery. The stupid rivet layout, accidental though it was, became a symbol of how ordinary people, working tirelessly behind the scenes, can have an extraordinary impact. The anonymous factory worker who made that decision never sought fame. He returned home after the war like countless others, living quietly while the planes he helped create changed the course of battles across the globe. The ripple effect of this minor adjustment reached far beyond fuel efficiency or range. Entire Allied strategies were altered because commanders could count on the B-24 to reach places previously inaccessible. Bombing campaigns became more ambitious, allowing strikes against key industrial centers and disrupting enemy supply chains. Rescue missions, reconnaissance flights, and even support for ground troops relied on the extended capabilities that stemmed from that one factory floor instinct. The margin of error became manageable, and countless lives were saved, both in the air and on the ground. In reflecting on the B-24's story, one can't help but see it as a lesson in humility and human ingenuity. In an era dominated by calculations, blueprints, and the rigid discipline of wartime production, a single, untrained mind, acting on instinct, made a choice that outpaced the most brilliant engineering minds of the time. The plane's remarkable range wasn't in the design manuals, it was in the subtle imperfections, the human touch, the stupid rivet layout that turned an ordinary bomber into a machine capable of extraordinary feats. When we watch the black and white photographs of B-24 lined up on airfields, engines steaming in the morning fog, it's easy to focus only on the pilots and crews, the heroes who flew into flak-laden skies. But the real story lies in the details, in the rivets and panels, in the quiet, unseen work of men and women whose intuition shaped the outcome of history. Each bomber that returned home carried with it the hidden genius of that one small choice, a choice that no one predicted, no one planned, and yet changed everything. By the war's end, the B-24 had flown more sorties than almost any other bomber, racked up millions of miles in hostile skies, and become a symbol of Allied industrial might and ingenuity. And while stories of aerial heroism dominate history books, the secret of its exceptional range reminds us that even the smallest, most unassuming decisions can echo across time. A rivet, hammered in slightly differently than planned, became a catalyst for one of the most remarkable engineering accidents in history, a small act that had an immense, tangible impact on the air war, on the lives of crews, and on the ultimate outcome of a global conflict. The B-24's legacy, therefore, is twofold. It is a testament to industrial ambition and innovation, and it is a monument to the quiet, unseen human decisions that can make all the difference. That stupid rivet layout reminds us that genius is not always found in laboratories or war rooms. Sometimes it is in the hands of a factory worker, trusting instinct over instruction, and in doing so, unknowingly shaping history in ways that no one could ever have predicted. As the sun set over Willow Run and the last B-24 rolled off the assembly line, the world was changing. The war was far from over, but the impact of that small, unnoticed choice was already written in the skies. Every extended flight, every mission completed, and every crew that returned safely was a testament to what happens when human intuition meets industrial power. And though the factory worker may have returned to obscurity, his legacy soared across oceans, skies, and history itself, a quiet, uncelebrated hero whose decision to adjust a rivet forever changed the course of the war.